Welcome to the Slop Temple. We pray this video helps.
You begin by rewriting the polynomial in standard form and factoring any common factors. This reveals real zeros and multiplicities. Identify the degree and the leading coefficient so you know the end behavior. Even degree same direction ends, odd degree opposite ends. Then locate x-intercepts from factored terms and note multiplicity to predict whether the graph crosses or touches. Once done, mark intercepts on the axis so you have anchor points for the next steps. You now plot the x-intercepts and the y-intercept, using exact values when possible to keep accuracy. Examine each root's multiplicity. Odd multiplicity means the graph crosses, even multiplicity means it touches and reverses. This explains local behavior. Use sign testing between roots to decide whether the curve is above or below the axis in each interval. Then estimate turning points from changes in sign and multiplicity to shape the curve smoothly between intercepts. You finish by drawing a smooth curve through the intercepts and turning approximations, ensuring the ends match the leading term prediction. If precision matters, compute one or two extra y values or use derivative estimates to refine slope at key points. Finally, check continuity and symmetry. Polynomials are continuous with no breaks. If the sketch still looks off, recheck factoring and sign tests. A wrong sign or multiplicity is the usual culprit. Correct that and redraw to resolve mismatches.
Thanks for watching. Consider subscribing if we helped you.